Okay, the first part of this video, which is page 16 in your notes, is just quickly talking about which method would be good to solve which type of question. You can solve a linear system by any method and you would arrive at the same answer. Based on the equations given, one method might be easier than another. So let's figure out what method might be best for these systems and maybe why. So for letter A, would it be easy to do graphing? No. I'd have to get y by itself. That's kind of yucky. Substitution, I'd have to get a letter by one of the variables by itself, and that's not great. This one would be best with elimination. I could just multiply the bottom by 2 and the top by 3. So top times 3 and bottom times 2, and then add them. No variables by itself. No y variables by itself either, so that's kind of going to be elimination as a choice. For part B, one variable is by itself. That means I would probably substitute the 8y plus 3 in for x in the top. A variable is by itself. And then for this one, I don't think I'd graph for any of these. This one I'd probably also use elimination. No variables by itself, no y's by itself. I could multiply the top by 4 and the bottom by 3, and then subtract. I could multiply the top by 5 and the bottom by 2, and then add. I kind of like that better. So 5 and 2, because then the y's would cancel out. But elimination is usually going to be the best method. Okay. So using your graphing calculator is a really important thing to be able to do. You can use it to solve a linear system. The process is the same as solving by graphing, where you graph both equations and the solution is the point of intersection. So we're going to use the graphing calculator to solve this system. X minus y equals 5, 3x plus y equals 3. We have to make sure both of these equations are in slope-intercept form. Your graphing calculator is not good at anything but slope-intercept. So if I change this one, x minus y equals 5, I could add y to both sides, and I'd get x equals 5 plus y, and then subtract 5. I would get y equals x minus 5. For the second equation, 3x plus y equals 3, I could subtract 3x from both sides and just get y equals negative 3x plus 3. So this is where the graphing calculator comes in. Let's see if I can make this work. Nope, not exactly. Okay, so when you're on your graphing calculator, we're going to put both equations into the y equals. If I go up here, the button literally says y equals. It has y1, y2, y3, lots of y's. So we're going to type the first equation, x minus 5. And the second equation, negative 3x, making sure to use the negative instead of the minus there, plus 3. And press graph. So you can see that they cross on this graph. So here's the fun part. If you press second and trace, above trace says calculate, calc, second, trace. There's an option, number 5, that says intersect. We can find where the two lines intersect. So I'm going to select it. The calculator places a flashing cursor on one of the lines and asks first curve. It's asking, is this one of the lines you want to use? So you press enter. Now there's a flashing cursor on the second line, and it says second curve. Do you want to use that one? Press enter. Then the calculator asks you for your guess. This means we should use the arrows to move that flashing cursor to where we think the lines cross. Around where? It doesn't have to be exact. I know it crosses somewhere around here. So when I press enter, it gives me the x and the y value where they intersect, 2, -3. So that's one way we can check what the answer is to a system. Okay, why is this being weird? Here. So we got 2, -3.